Welcome to section 3A. It's a beautiful day, aren't you excited? Okay, so 3A talks about uses and abuses of percentages. It starts by doing some review of percentages and how to change a percent to a fraction. All of this is stuff that you really should already know. If you are in a prerequisite class, we go over some of this, and feel free to go back and look at that. If you're not in a prerequisite class, then if you don't remember how to do this, there's this little teeny tiny little snippet at the very top that will help you. And if you don't understand that, you need more practice on it, please get in contact with me, because you really need to be able to do this very well in this particular class. So to go from a percent to a fraction, you just divide by 100 and simplify. So I'd take the 25% and do 25 divided by 100. Then I'd simplify that. I can divide 25 and 100 by 25, which will give me 1 over 4. That's my simplified fraction. To change 5% to a decimal, I drop the percent sign, and right now it is at 5%. Move my decimal 2 places to the left, which makes it 0.05. That's my decimal. To change 0.43 to a percent, I would move it 2 places to the right. So put my 43% in, put my percent sign back. There are 2 little zeros in the percent sign. That's how you know it's 2 places. To change a fraction to a percent, you're going to have to go ahead and do your division. I would suggest using your calculator for that. It's a lot faster. You divide to get the decimal. When you use your calculator, you say 1 divided by 5. It'll go ahead and give you the 0.2, and then you can move it as we did before to get the 20%. I would suggest you use your calculator because you're going to have that calculator available to you. We're not telling you to be able to do stuff without your calculator. We want you to use your calculator. Please make sure you have the right kind of calculator. You cannot use a calculator on your phone. You cannot use the calculator on your phone. It's time to grow up and use big boy calculator. If you don't have a calculator, you can always go to a pawn shop and grab a calculator. Or you could walk to the dollar store, get a calculator there. I'm telling you, calculators are not that expensive. The kind of calculator we want you to have, not that expensive. You don't have to have the fancy one that we're telling you to get in this syllabus. You just need a 4-function calculator that is scientific. It's really not that hard. It doesn't have to have anything excruciatingly fancy on it. It'd be great if it had the little parentheses on it. As long as it has parentheses on it, then everything that I tell you, you'll be able to type in, and it'll be grand and wonderful. If it doesn't have parentheses on it, we can work with it. I'm telling you, we can work with just about anything you get. But if you get what's in there, it's like a $12 calculator at Walmart. It's not excruciatingly expensive. Grow up, get your real calculator. Doesn't have to be the $100 calculator. We're not telling you to get a graphing calculator. Don't want you to get a graphing calculator. You don't need that fancy of a calculator. Just get a calculator. That's your adult conversation for the day. Okay. Enough said. Calculator. Just say it. Get a calculator. Alright, so the key word of, we had talked about before, means to multiply. You know, is means equals, of means to multiply. Long time ago we did part and whole. equals percent over 100. That's how you were supposed to set up your percentages, your proportions. Some people did is over of equals percent over 100. That was a way to set up your proportions. Either way still works. Sometimes you get really easy proportions like that, and it's easy to set up. Sometimes you don't even need them to be that easy. Sometimes it's just easier to set up the part over the whole. Sometimes it's easier just to read the directions. Just saying. Check it out. Express the first number as a percentage of the second number. Okay, so since the first number is a percentage of the second number, let's go ahead and multiply and make a percentage out of it. Alright, so the first number is the 60 million. That's our part. They want it as a percentage of the second number, which is the 328 million. That's our whole. They want us to make a percentage out of this. So if this is our fraction and they want us to make a percentage out of it, the way you make a percentage out of something, once again, if they've got the millions, same thing on top as on the bottom, we can go ahead and cancel out our units. Just saying, it works that way. So I can cancel out my units, stick this in my calculator, and get a number. So my handy dandy calculator is going to tell me that this is 0.1859756. Then in order for me to change this to a percentage, I just need to multiply this times 100%, and it will make it a percentage, because right now it's a decimal. I want it to be a percent. And that's going to equal 18.5976, sorry, 756%. Generally speaking, we don't want them to be that long. This one didn't say the word around it to, so I'm going to go ahead and tell you that I get to choose. I'm going to round it to the nearest tenth of a percent, so 18.6%. Why did I choose 10? Why not? Just because it's what I wanted to do. It's where I rounded it here, my key. Why not? An opinion poll finds that 64% of means to multiply. When I'm multiplying with a percentage, you know, it's supposed to be 64% of this 1069. People surveyed said that the president is doing a good job. How many people said the president's doing a good job? I can't do 64% times this, because when you're multiplying percentages, you can't have a percent sign in your problem. You have to change it to a decimal. So in order for me to change it to a decimal, I got to go ahead and take that percent sign out, which means I'm going to have to move my decimal point over. Right now my decimal point is where the 4 is, behind the 4, so I'm going to have to move it 2 places over. So that changes it to 0.64 times 1069. You cannot have a percent in a computation. You must change to a decimal. Haha. Look, I got all fancy. Aww. Did you do that in your notes? I was just putting it in there so you could see. I bet you didn't think I'd get this cheesy, did you? You gotta stick through to the 4th video to see me get this cheesy, but it happens. Oh, okay. So, when you multiply this out, you get that it is equal to 684 people. Because you want to round to the nearest person. You don't get exactly 684 people. I'm just saying, you want to round to the nearest person though. You don't want to leave it at a fraction of a person. That's not nice. 112 freshmen is, we said is was the same thing as equals. 26%. I'm not even going to write the 26% in. Instead, I'm going to go ahead, since I'm writing my equation now, I'm going to go ahead and write my 0.26 because I know what's coming. Of the school's entire student body. I'm just going to go ahead and say X. Because of means to multiply, right? So the school's entire student body is probably going to be our X. How many students attend the school? That's their entire student body. We want to know what X is. In order for us to figure out what X is, we going to have to divide. So I'm going to divide by my 0.26 because that's how you get to X by itself. 0.26. Got to throw a little bit of algebra in there. It's a trick. I put a little bit of algebra on it. 0.26. They cancel each other out. And you get 112 divided by 0.26. And X is going to equal... See, 430.77. You don't want a 0.77 kid. That's not nice. Not nice. It's not politically correct. It's not politically correct. Or 431 students. Let's be nice. Other keywords you need to think about could be increase, decrease, change, and than. Increase and decrease and change. Increase obviously means it's going to be going up. Decrease means it's going to be going down. There might be some pluses and minuses going on. Change means it's going to change. Don't know how it's going to change. And then, that could be some flipping stuff going on. We'll talk about that a little bit later on. When we talk about the code, we'll get to the code. We'll discuss the code. Old increased, decreased by percent to new. New is percent more or less than old. Old and new. You know you're really not supposed to call old people, people old or new. It's not nice. But we're going to talk about old and new. We're going to talk about reference and compared. Because we have to talk about something called absolute change and absolute difference. Absolute change has a formula, and absolute difference has a formula. They are not the same formula. I know you're wondering if you have to memorize them. You no longer do. Sorta. They kind of gave the wrong formula. How about that? It should be old value, not reference value. Whoop. Well, what do I know? For the absolute change, it is technically, you're talking about over time. For absolute change, it's a time thing. So you have new, which I refer to as N, and you have old, which I refer to as O. For absolute difference, you have compared, which I refer to as C, and you have reference, which I refer to as R. So the formula for absolute change is simply N minus O. That's it. That's all of the formula that there is. That's the formula. That's all. N minus O. New minus old. For absolute difference, it's C minus R. It's not very difficult. Now, you can tell which one the new and the old is because they'll tell you which one's new and which one's old. You look at the dates. For compared and for reference, they don't really tell you which one's compared and which one's reference. What they do sometimes tell you is that the compared value is always the first value that they list. I mean, always. It is always given first in the problem. Always given first in the problem. Always, always, always given first in the problem. Now, in addition to being able to do the absolute change and the absolute difference, you have to be able to do the relative change and the relative difference, and they have different formulas. So for relative, you need to understand that they are wanting percentages for both of these. That's what relative means. It's going to be a percentage. So for relative change and for relative difference, you're going to have to make sure you get a percentage. So the formula is N minus O divided by O times the 100%, so you can get that percentage. And this one is C minus R divided by R times the 100%. They're very similar formulas. That's why we teach these together. Your question is, do we have to memorize these formulas? No, they're on the formula sheet. There is a formula sheet. It is on the midterm. It is on the final. Be right there for you. Right there, slapped up there for you to grab and look at anytime you need. These are on it. So you'll be able to see them. But you do need to know that about the compared value always being given first, because that's not on the formula sheet. You have to be able to use the formulas. So the estimated number of refugees in the world increased from 8.7 million in 2005 to 26 million in 2020. Find both the absolute and relative change. Well, they told you which one to use. They want the relative change and the absolute change, so you know which formula to use. However, even if they didn't, you can tell that this one has to do with time, right? Because they gave you dates. So we'd be able to figure out based on the dates which one's the old one and which one's the new one. The new one must be the one from 2020. So this is our new value, which makes this one our old value. Label them first. It'll help you out. So for absolute, we have new minus old. Our new was 26.0 minus our old is 8.7. That gives me 17.3. Million. I didn't have to write the millions out because they're both in millions. So I didn't have to write them out. If they would have been different, so if one would have been billion and one would have been million, I would have had to have written all those numbers out behind them, all their zeros out. That would have meant that I would have had to have calculated and stuck it in my calculator to figure out what the answer was. But because they were the same unit, I didn't have to do that. So be careful and make sure your stuff is in the same unit before you start jumping to conclusions about things, okay? So my absolute change is the 17.3 million. For the relative change, we have n minus o over o times the 100%. So that's going to give me the 17.3, because that's what we just said n minus o was, over my 8.7, because that's what the o is, times the 100%. You're going to want to do this division in your calculator before you ever multiply it times 100. So do the division and press enter first, and then you can multiply it by 100. And you're going to end up getting 1.9885 times 100%, which gives you 198.85%, which is roughly 199%. I'd take both. Example 5 says, in 2020, the median age at first marriage of U.S. women was 27.9 years. And that was blank percent less than the median age at first marriage of U.S. men, which was 29.7 years. They want to know what percentage less it was. They didn't tell us which formula to use. Did they give us a couple of different years? No. So we can't use the absolute and relative change because it's not new and old. So we're going to have to use the compared and reference. So if we use absolute difference, and do compared minus reference and relative difference. And get compared minus reference over reference times 100%. My compared is the first one they mentioned. Well, the first one they mentioned was this one. So that's my compared, which makes this one my reference. So it must be 27.9 minus 29.7, which in this case is negative 1.8 years. Can it be negative? It can be negative. There's nothing wrong with it being negative. In fact, we knew it was going to be negative because it's supposed to be less. Less would imply negative. So that's okay. That means that my top number up here is going to end up being a negative 1.8. Over, my bottom number was my reference, 29.7 times the 100%. The negative 1.8 divided by the 29.7 gave me a negative 0.060606 dot dot dot, because it keeps on going, times the 100% gives me a negative 6.06 dot dot dot, which is negative 6.06%. You gotta round it off somewhere. Gotta round it off somewhere. Converting between part, whole, and comparison. If the new or compared value is p% more than the reference value, then you're going to add 100 to that. If the new or compared value is p% less than the reference value, then you're going to subtract it from that. If you have a discount and you discount at 30%, that means you're really only paying 70% of it. That's where they get that you're subtracting it from 100. If you're paying 20% tip, then you're paying the whole bill plus the 20% tip, so you're paying 120%. That's where they get that from. So when we look at the population of Michigan is 63% greater than the population of Missouri, so Michigan's population is 163% of Missouri's population. The population of Hawaii is 52% less than the population of Arkansas, so the population of Hawaii is 100 minus the 52%. This one was 100 plus the 63. 100 minus the 52 is 48%. The wholesale price of a toaster is 30% less than the retail price. Therefore, the wholesale price is blank times the resale price. You want to say that it's 70%, right? But since they say times, ooh, I bet my math lab would put that, because you don't multiply a percentage. Just saying. I understand you writing the 70%. I bet my math lab will put that. The original retail price of a TV is 20% more than its on-sale price. Therefore, the retail price is 1.20 times the on-sale price instead of 120%. Bet my math lab would put that instead of writing 120%. I bet. A store is having a 25% off sale. The sales price for an item with a regular cost of $120 is I can't say it. I'm not supposed to say it. Sorry, I was reading. Shh, don't say it. Sorry. The store is having a 25% off sale. The sale price for an item with a regular cost of $120 is. It usually costs $120. They want it to be 25% off. If it's 25% off, that means you're actually paying how much? 75%. 120 times 75% is $90. There we go. Okay. Your total cost for dinner in a restaurant after the tip was, assuming you left a 20% tip, what was the bill for food and taxes? Your total cost in a dinner after the tip was, so you paid $76.40 after the tip. So you paid 100% of the bill plus 20% of the tip. So you paid 120% of the cost of the meal. So we need to divide by 1.20. And we get that x is equal to 63.67. If you're having problems with the algebra end of things, you need to contact me and let me know so that I can make sure you get some help with that. If it says percentage points, it's referring to an absolute change in percentages. 2 percentage points more than 4% is 6%. Beware of shifting reference values. An increase of 10% by a 10% decrease does not give you the original value. This is a question that happens a lot. Don't average percentages. If you have a cumulative GPA of 2.0 after taking 30 credit hours, this semester you took 12 credit hours and got a GPA of 4.0, your cumulative GPA is not 3.0. These questions right here, these last two, directly correspond to questions that are asked either on the midterm, on the final, or in my math lab. They are things that will give you answers to those directly. So make sure you pay attention to those. That's why I started them. Little tidbits of information, directly giving you information about those. Sorry the video was so long. Hope you understand.